keep it short, so later on we can go and get some food for our stomachs. But let me first put it into some context. So first context is about the company. Wigo is a travel meta search. You come to us, you search for a flight, or you search for a hotel, and we are pulling all the prices, all available offers over the internet, and we're showing them to you. That's maybe similar to Kayak or Skyscanner, depending if you're coming from Europe or US. Wigo is concentrated mainly on Southeast Asia and Middle East, and we are based in Singapore. So we are very much a web-based startup, and we do big data. As a Google guy just said, if you're doing search, every problem that you have is a data problem. So we do big data, and what's the big data context? Everybody is talking about creating infrastructure. Looks like infrastructure is a solved problem to me. Actually, even in this conference, I'm getting so many questions. How big is your data? People measuring the data in terabytes. Well, theoretically, I can get a HD camera, start filming my office, and the raw storage of, if I store the video raw, 1 week is about 600 terabytes already. It depends on whether you implement conversion or not. And it's easy to scale. I can buy 5 cameras, 10 cameras. The key problem is, okay, this is your data. It's a pile of data. Where's the value? And there is a common path, the good path, the right path. People normally start with the problem. Then there is some analysis. Today the tools are cool. You can get everything in seconds. You query the data. You can apply some cool predictive models if you really like. And hopefully you get to some results. They convert into actions. And this is how you get the value. But here's the problem. It looks to me that we are still asking the same questions, even after we got so much more data in our storage. Our ability to ask good questions, it's a brain. Fernando, he was talking in the morning about it. Yeah, you need a brain on top of your data. And okay, we've got all these tools. The helicopter heads and Google invented the infrastructure. We are actually using it a lot. But they didn't come to our company. We still need to ask good questions, and we probably don't have that many good questions. So my problem is always, okay, how do I get the value if I can't invent too many questions? So the idea is that we can look at the data and discover something we didn't know, even without a particular question at hand. That's the context of the trick that we are using in Wigo a lot, and I wanted to share it with you. We are web-based, so there was a long history of this technique or idea that in web analytics is called user path analysis. The idea seems very cool. You follow the user. User is leaving the trace on your website. For us, would be very simple. We essentially have 3 pages. You land, you search, you see the results, you helpfully click on something and head off to book a ticket or to book a hotel. Sounds like a good idea. If you try Googling about this technique and tools used, you will find out that every single analytic expert wrote a post on his blog about it. And the consensus is it is useless. More precise, one of the big guys wrote that, okay, if you absolutely have nothing to do and you don't want to go home, that's probably the time. Why? Because it sounds so cool. The problem is combinatorics. If I go and look at user behavior on my website, on Vigo, and it probably applies not only to web, but to any customer-facing businesses. The top user path is bounced user. He opened the website, said, oh, shit, closed it. That's it. All the users that bring value are unique. They are very different. And if I want to look for the common path, for the most common path, I don't see the real value. It's somewhere down the line. And the common strategy that I see evolving, even Google Analytics added it, is to reduce the details. So now they have these user path tools, and they allow to group your pages into some clusters. If you have hundreds of pages, you say, okay, this is stage 1 pages, these are stage 2 pages, and you just follow transitions between stages. Doesn't work for us because we just have 3 pages, and doesn't really add any value because you are missing the important details if you're trying to do this. The big data is about details. It's not only about how many transactions you store, but how much features do you have there, how much do you know about these users. And the way to fight combinatorics is to exclude all this information. So we thought about it, and we tried to fix the concept and to marry it with a different way. So the analytics way is the common path analysis statistics. As I said, doesn't work that way, but also almost all startups and probably many other organizations now, they're switching to agile technologies. Banks maybe do waterfall still. So agile, I'm a product owner. What is the methodology for me? It's a user story. I'm writing user stories with a lot of details about the customers using our product that we design, and I'm telling to our developers, okay, this is your user. It's actually a fake story. That's the downside. It's a story that I would invent myself because it's my experience of my friends. But the idea is to marry these two together. And what happens, we try to look at one user instead of looking at an average, the most common user. We're just looking at one. And then you can add all the possible details. Because it's just one user, you don't suffer from combinatorics. How does it work, and how does it look like? So you probably, if you're at like relational stage or relational databases way of doing things, you have different tables with events, people visit, people do searches, people convert, not like several event types, and you store them somehow. We switch to big data tools. Then the most common methodology is denormalize everything, big tables, big data. So I have a huge table with all the data I have about one user, and it's a sparse table. You can't really read it because it has maybe thousands of fields. Some fields relate to this event, some fields relate to that event. It's unreadable. Turns out there is a simple trick to convert this table already into a story. Because we still know, okay, this is the user ID, this is the timestamp, we know the order of events. We can compact all the unreadable data into a simple story about one user. I call it some natural language generation. It's not the IBM Watson thing. IBM Watson, they're trying to do a complex problem, natural language to structured data. You have structured data to natural language. It's super easy. And then as a result, you get a story about one real user with all the details inside. So this is actually very superficial, just to fit on the slide to keep the font big. The actual story would have much more details. Yeah? But you still can see a user who is actually doing something interesting. He's coming from Saudi Arabia, trying to fly from Jeddah to Paris, and he's trying to do a leg search. He's trying to find cheaper tickets through Dubai. That's just one of the patterns, and as a product, as a search engine, we probably want to know how many people try doing this, and maybe we can make their life easier. So yeah, that's the trick. And how does it work? First of all, you include as many details as possible. Second, it's a story. It's a holistic approach. You're not looking at numbers. You're looking at one user. You can try to guess user motivation. I can very much relate to recording the voice when you can hear the emotions of the person. This is great if you have it, we don't. But even following one user, following his behavior on the website, it's not linear, it's not straightforward. Nobody is going 1, 2, 3. Everybody is doing something different. You can guess the motivation. Again, if you have a problem with your product, most users will silently go away. Oh, I don't like you. That's it, you lost your customer. But some people are freaks, they're crazy. They try to solve the problem with your product, repeatedly going through the search form, web form. If you try following them, you can figure out at some point of time, wow, yeah, we're terrible people, we're torturing people with this web form. We're really bad. But of course, you're looking at one user, don't forget, this is like the early stage to discover the idea, then you go do the real statistics, how many people are like that, right? And also the trick is maybe looking at all stories at random is boring. You want to filter, you want to see the stories where people did something interesting or just generated a lot of money for you, the active users. So what's in, like, specifically for Vega and what is it good for? Yesterday there were several talks about data consistency, is our data correct, data governance. Actually, I find this method as a very good tool to find bugs in my data. Because I'm following one user, so it should be reasonable, there should be motivation between steps. If I see the user didn't visit it but did a search, or didn't search for anything but converted, well, something is really wrong with my data. Looking at statistics, you can't guess what can go wrong easily. This was the very good way to see that actually our data is bad in some sense. And then you find that your product is bad by following these frustration moments of the user. And probably the last, but not least, probably the biggest, is you get a very different gut feeling about your product and your user. People start understanding, okay, actually, it's not that straightforward. You don't just search for flight or hotel. If you're really going to buy it, you're probably going to come back for a week or two. You're coming from work, different IP address, the working day time. Then you come home, you show to your wife, different IP address, evening. I see this all the time. So you're understanding your user story that you're telling to your developers to create a great product becomes real. It's not that much your experience, it's a real experience of real users. Maybe for geeks outside, a little bit of technical details. Yeah. Luckily, we don't need to invent infrastructure. We're actually running everything on Google BigQuery. We don't have privacy issues. We can store everything online. Yeah, and as I said, generating natural language is not IBM Watson problem. It's very simple. It actually can be done just in if functions in the line. You compact, you make it readable. And how it works, we have a Google spreadsheet. There is a big button next user, and it's shared among all product guys, all people thinking about the product designers in our organization. And it's their Zen moment. They can click, and read through random stories. People's brains, they're very good in detecting patterns. If you put all the details inside, probably you can feed it to Google predictive APIs, but your brain is much better than what they do right now, right? So if you're just making this data available to your colleagues, they will figure out a lot of good questions. Of course, the last thing, it's just one tool, and it is a very, like the discovery tool, the description tool. Then you figure out something, you have a problem, you do your analysis. With the problem at hand, you can do KPI, statistics, you can do proper analysis, not just one user, but a representative sample. And probably you arrive to something. Well, hope I have persuaded some of you to try it. I really like this technique. It's not the only thing we do, but I just wanted to share something that I find interesting. That's it.
Thank you so much. Definitely have time for a few questions or such. Any? So as part of using Google and cloud and and that whole aspect, because we definitely sort of combining presentations and such. From as you would address security and so on and so forth, are there any issues, or what are some of your, WeGo's concerns with using the infrastructure, versus your own infrastructure?
Well, like we're not a bank, we don't have any legal limitations. And the reason we started to use somebody else, because otherwise we would have to build it ourselves. Not a good idea for a startup. The concern I have is, of course, what happens if tomorrow it just blows up. So the data we store separately. I have a backup of the data. So if something blows up, okay, I don't have the engine to deliver to you results in seconds as I do now, but I still have the data somewhere else. Okay, I will go after Hadoop, install it, suffer, but the data will be there for all the years that we have. So we have this kind of backup.
Right.
Yeah, and that's our strategy. That's the only thing. The second thing I always talk about BigQuery, so it's so cool. More people start using it, and then Google will never retire it. That's it. That's what will not happen with the Google Reader, all these technologies that they retire because they were not market leaders.
Yeah. All right. Very good. Anyone else? All right. Oh, great.
You're collecting a lot of data and storing a lot of data about how people search for hotels and trips and so on. Have you ever considering selling this data, not on the most granular level, that's sensitive, but have you considered selling this data to hotel chains or companies involved in traveling?
Well, we do.
You do, all right. Of course you do. Thanks.
Yes, there is one part of it which is user intention. So if you are looking to book a flight to Tokyo, and it's not only us, if you're doing this, not be surprised that somebody will start advertising you like a concert in Tokyo for these particular dates, because they know that, yeah, it was your intention to go there for these dates. Yeah, it might happen right now. Try it. And the second part, probably we are not, we are more against the guys like Marina Bay Sands, who is trying to play with the user prices to maximize the revenue. We are on the search side, so we're trying to serve our users better. So what we are doing, we are telling them, okay, this is the deal. Now the price is much lower than it used to be for Marina Bay Sands. We are storing this information because every time you do a search, we query all the providers. Okay, what is the price for this hotel, for that hotel? And we have it forever. So yeah, we can analyze this data and tell you, now it's a good deal. Normally, like this hotel costs much more. So probably you would like to book it.
So is it still 64 days ahead of travel the best time frame to be purchasing your ticket? I Googled that one day, and this was the result. 64 days ahead of your date of travel is the best time to be booking your ticket.
Well,
for pricing.
For pricing, I guess, yes, something similar. But you also get many providers that don't allow you to book more than 3 months up front or something like this. So
okay.
You probably don't have much competition.
Yeah. Well, I think very interesting look at a very specific type of search on a very specific type of data that we're all probably personally familiar with, at least on a weekly basis, travel. So excellent. All right, well, it brings us towards the lunchtime. We've been told that the hotel will have a little different process for getting us through lunch, probably a little more quickly and efficiently. So they're learning from their big data analysis. And so I just ask you to obviously continue the conversation throughout lunch. Enjoy lunch, and we'll be getting together back here for starting at 1:30. So if you can arrive back a little ahead of time, since we have some time, that'd be great. And